Okay, so it says you got a rigidly attached wheel. Moment of inertia is I equals 2.2. The torque is 4.4 Newton meters, and the time is 0.6 seconds. And it's asking what final angular velocity would it reach? Basically, we don't know the radius of this circle, and we don't have to know. It's the motion of the entire circle, which is interesting. So I'm going to draw my location. Here's my 4.4 Newton meters of torque. On some radius, we don't know. 0.6 seconds worth of time. We don't know the angular momentum yet, but we can find it. If it starts from 0 radians per second, how fast will it end? That's the question. There's actually two ways that you can take this. For example, you could find the angular momentum of the object, because change in angular momentum is angular impulse, right? So torque times change in time, if I push with 4.4 Newton meters for 0.6 seconds, that'll give me a momentum. And if I started from 0, then I know what my momentum was. So 2.64 appears to be the, wait, did I do that right? Okay, so I always like to double check. I don't want to keep making mistakes in front of you. I'm trying not to give out too many of those today. We'll see. All right, so if you got momentum, momentum at the end here is going to be its final momentum, right? So the other formula for momentum, moment of inertia times how fast you're going, right? Or I guess it's not really delta L anymore, it's just L. But now we know what the L is, 2.64. And we know what the I is, it's a 2.2, right? Times some speed. So in other words, momentum increased until it had 2.64. And then how fast would a 2.2 kilogram meter per second or kilogram meter squared object have to be going to have this momentum? So we can divide. So how fast is it going? $1.2. Okay. The other way to do it is just to go straight for the neck and say, well, I don't want to waste time on this secondary calculation. Let's just go for it. Torque is also moment of inertia times angular acceleration. It's Newton's third law, but for angular. So I'm sorry, Newton's second law. F equals ma, right? Torque is the angular equivalent for force. Moment of inertia is the angular equivalent for mass, and angular acceleration is the angular equivalent for an acceleration. So we actually solve for an acceleration here, and we could say 4.4 equals 2.2 times alpha. What does that make alpha? 4.4 divided by 2.2. Is that just gonna be 2? Okay. So 2 radians per second squared. And now you can kind of think about kinematics, right? If I accelerate at 2 radians per second for a time period of only 0.6 seconds, what would that look like for my final speed? So if acceleration is change in velocity over time, angular acceleration is going to be change in angular velocity over time. And we know 2 out of 3, right? So 2 equals some number, and it's 0.6 seconds. So what operation? I think we're going to multiply, right? So if we multiply 2 and 0.6, I think we'll get the same number. 1.2. So if you said D 1.2 radians per second, you're correct. I guess there might be a third way to do it, but these are the two easy ways.